So guys, till now we have learnt about different substitution reactions. We have learnt about SN1, SN2, SNI, internal nucleophilic substitution, SN2, and we have learnt about NGP. So today we are going to compare between SN1 and SN2. We'll compare different factors which can direct a reaction towards SN1 mechanism or SN2 mechanism, and then we'll solve some questions to get a clarity on how to apply all these concepts what we have learned individually. Okay, so let's quickly compare. All this information we have already discussed in different classes and in different videos. So this is kind of a summarization of SN1, SN2 as well as a comparison. So first comparison is in terms of mechanism of reaction. So let's first distribute the whole thing into three categories. This is about SN1 and this is about SN2. Okay. So how the reaction would be? Rx will react with nucleophile, will form a carbocation R+, and then RNU will be formed. In this SN2, we have Rx dividing by reacting with nucleophile. Nucleophile will do a back attack, will form NURX, which will get converted into NU and R. Okay. Next is the comparison in terms of solvent. Solvent, what we take here is PPS, polar protic solvent. So polar protic solvent supports SN1 and PAS supports SN2. What is PAS? Polar aprotic solvent. Now, nature of nucleophile. Weak nucleophile favors SN1 and strong nucleophile favors SN2. Next is nature of leaving group. In both the cases SN1 and SN2 we need a good leaving group, because bad leaving group will not leave the molecule easily and hence will make the reaction difficult. So weak nucleophile will neither favor SN1 nor will favor SN2. Next is rate of reaction. Rate of reaction for SN1, rate is directly proportional to the concentration of reactant. Here rate is dependent on the concentration of reactant as well as nucleophile both. Molecularity of the reaction. This is 1 and this is 2. Next is order of reaction. This is again 1 and this is 2. And when it comes to what degree of carbon it should be when we have to go towards SN1 or SN2, degree of carbon which is attached to leaving group. So degree of carbon, tertiary favors SN1 maximum, then second, then primary. So order of reaction is tertiary, secondary and then primary, and it is completely opposite in case of SN2, primary, secondary and tertiary. Why here it is tertiary, secondary and primary? Because the carbocation formed for the tertiary will be the most stable, then secondary and then primary. Whereas in this case we go by the steric hindrance. So steric hindrance is least in primary and maximum in tertiary, hence the rate of reaction decreases if the leaving group is attached on a tertiary carbon. Okay. Next is about transition state or intermediate. So SN1 reaction goes through at least 2 transition states and 1 intermediate. Whereas SN2 goes through one transition state. Next is about stereochemistry. So the product formed by SN1 will be racemic mixture. So retention as well as retention plus inversion both will take place. In case of SN2, only inversion takes place. Inversion of configuration takes place. Please note this down, and then I'll just write one more factor over here. Factor, or the factor which can help us in comparing between SN1 and SN2. Third one is, I hope this is visible. So next is potential energy diagram. For SN1, the potential energy diagram goes through double peaks. So potential energy diagram is like this. That's how will be the potential energy diagram for SN1, and this is how the potential energy diagram of SN2 will look like. Okay, so these are few factors which can affect the rate of reactivity of a molecule and can direct the reaction towards SN1 or SN2. So when we are talking about the degree of reactant where the leaving group is present, as I have already mentioned that for SN1 we require the order is tertiary, secondary and primary, and for SN2 it is primary, secondary and tertiary. So we can also write it as, when we are talking about primary, secondary and tertiary carbons where the leaving group is present, tertiary will mostly favor SN2, and primary will mostly favor SN2 and tertiary will mostly favor SN1, whereas in case of SN2 both are possible, SN1 and SN2. So we cannot decide on we cannot decide just by looking at the carbon chain whether the reaction will go through SN1 or SN2. Instead we will have to look upon many other factors what we have listed over here. That is the reason why in maximum competition exams they give you a compound which will be a secondary compound, and they will give you such a question so that you can analyze all the other factors and decide whether in which direction the reaction should proceed. So we will do some questions now. I'll write down some questions, note them down, try doing it and try to identify whether the reaction is going through SN1 or SN2, and then we will discuss.